Hello, everyone. I'm Ryan Fox, developer advocate at Algorand, and it is my greatest honor to be returning to the UDC 2022 stage. Well, that was me 10 years ago when I was working in mortgage banking by day and mining Bitcoin at night. And, okay, how it started. There we are. Here we go. So here's the meme. And how it's going. All right. No, see, now we went too far. I hope that you connect with me on Twitter. I'm Ryan R. Fox, and also the Algo Devs as well. All right. UDC 2022 has this great theme this year, right? Imagining your blockchain life. And I want to modify just ever so slightly to talk to you about developing your blockchain life. I'll focus on you, the developers, because I want you to be developing on Algorand. All right, I want you to build smart contracts. I want you to build decentralized applications, DeFi, NFTs, gaming. I want you to build blockchain-based games. I want you to build oracles to bring off-chain data to those other smart contracts that we talked about earlier. I want you to build bridges. I want you to build trust-minimized bridges that are decentralized and are built at layer 1. And I want you to build bridges using our just released state proofs technology. And I want you to build bridges to other devs as well. I want you to build community as a developer, as a creator, and as a Web3 user. In short, I want you to build the future of Web3. And I want you to build it all on Algorand. I welcome you to the Algo fam. Let's build. All right, so this talk is going to focus on these 3 topic areas here. I'm going to introduce you a little bit to our tech, show you how to build with it. Firstly, I want you to know that Algorand is a layer 1 blockchain, and Algorand is a technology company. And we're focused on delivering open source, decentralized solutions. Algorand is full of talented people focused on building and maintaining valuable relationships. And finally, Algorand provides the developer tooling so you can build your blockchain life. All right, so I'm going to spend about the next hour or so here talking about these points. No. Algorand doesn't do anything for an hour, all right? Algorand is not like the old proof of work blockchains, nor is it like some of the modern proof of stake blockchains that talk about minutes. Heck, Algorand doesn't even deal in minutes. Nope, Algorand is fast. We are arguably the fastest layer 1 smart contracting protocol. Today, our block times are under 4 seconds. We are finalizing and committing all of those transactions in 3.7 seconds. That means that on Algorand, your block is final when it's committed, and any transactions in there cannot be rolled back. That is proven by mathematics. Algorand is scalable, and this means that we are meeting the needs of the Web3 future today. We can support 6,000 transactions on mainnet. Algorand is built for the enterprise and the speeds they need. Algorand is decentralized. Our novel, pure proof-of-stake consensus algorithm enables public permission sets of nodes. We have over 1,600 nodes active right now on our mainnet, securing our network. Algorand is secure. Our sortation algorithm for pure proof-of-stake selects the leader using a verifiable random function. In the past week, one of our validation nodes was holding only 2.5 algos. That's less than $1 worth of value, and they were selected by that verifiable random function to participate in the consensus system. This is really incredible technology that is fostering decentralization and security. And it runs on commodity hardware, so everyone can participate in this public, permissionless blockchain built for the future. Algorand is smart. At the pinnacle of cryptography contributions is our founder, MIT professor Silvio Macaulay. He has won the Turing Award, which is the highest honor in the field of cryptography. It's like the Nobel Prize for crypto. He is the inventor of zero-knowledge proofs, and that's used extensively throughout other blockchain protocols. We've heard a lot about zero-knowledge today. But not just Macaulay. The depth of talent on the Algorand research and engineering team is second to none. Algorand is green. We use a smart contract to calculate our electricity usage, and we partner with Climate Trade to purchase carbon offsets. Climate Trade has built a carbon marketplace right on Algorand so that we can do this. Speaking of fast and green, I want to tell you a little bit about one of our partners, the Envision Racing Formula E team. Now, maybe you had the opportunity to see this car racing on the track in Seoul just last month. It's a completely electric race car. And the Envision Racing team is focused on their race against climate change. And their aim is to accelerate the transition to clean, secure, and affordable renewable energy and speed up the mass adoption of e-mobility. Algorand are fast and green, just like this racing car. More racing, how about the Drone Racing League? This organization is focused on, is a builder-focused organization where we have pilots and drones racing through these lighted gates towards their victory. Both Algorand and the Drone Racing League are disruptive within their respective industry. One reason the DRL partners with Algorand is to provide a platform for innovative fan experiences. Innovation is the focus of their first project, the Project Drone Galaxy, which is first fly-to-earn gaming app, which will be coming soon. Fans have the ability to select their drone pilot, their drone vehicle, the parts, and then level them up as they race. All of these player interactions are assets on the Algorand blockchain, and their actions are reflected on the blockchain as well. That's Web3 in your blockchain life. And that is what Algorand is leading on in innovation, Web3 and gaming. A bit more about gaming. This time, FIFA, the world governing body for football. You'll recall our founder, Macaulay, here on the right, along with FIFA president Gianni Infantino. FIFA recently announced that Algorand will become the official blockchain platform of FIFA. In that announcement in May, Infantino is quoted as talking about the innovative challenges for sustainable revenue growth for further reinvestment back into football, ensuring their growth on a global scale, and ensuring transparency all the same. And that's 2 points that Infantino is making where Algorand are excelling. That is transparency and their global nature. Now, the first tangible representation of the Algorand partnership with FIFA is their recent announcement earlier this month about the FIFA Plus Collect. This is a new platform which will be allowing fans to own and collect FIFA World Cup and FIFA Women's World Cup moments. This is an announcement that will be coming later on this month, and we're really excited to see what comes from it. FIFA have over 1 billion users, or I should say 1 billion fans. They will become users of the Algorand blockchain, And FIFA has selected Algorand because we have the technology and the solutions to meet these fans on a global scale. So think about some commonalities here. Think of Envision Racing, the Drone Racing League, and FIFA and what they share. They're all transitioning their fans or their customers towards Web 3. They're transitioning their technology to the Algorand blockchain. And they're doing that without their fans knowing that Algorand is underneath. And that's the best way that you're going to know how you're succeeding in your blockchain future, when you develop solutions where the end user don't even know that it's blockchain technology underneath. So how do we do that, right? Or why do we do that, right? And that's because we want to provide a great developer resources to build Web3 solutions today. We have over 2,000 teams that have built innovative Web3 projects on Algorand right now, and I'm ready to show you how they did that. It all starts here at the Algorand developer portal. Come here, click, make sure that you click the connect button up here in the upper navigation section. Join our Discord. We've got 37,000 users on our Discord channel. Connect with us on Twitter. We've got 300,000 Twitter followers there. Come and join the Algo fam. Create an account by connecting or by using your GitHub authentication to log in. And I'm going to invite you to perform some challenges where you can earn an NFT badge. So here's what you're going to do. Select a challenge, read the description, select your preferred SDK, and then an IDE is going to pop up where you are going to be able to input your code, and when you successfully execute the solution, you'll submit it to the blockchain, and you'll be rewarded with an NFT to commemorate your learning. I look forward to having you do those. Get your quick start going on right here at the Algorand developer portal. Let's move on and show you what it actually looks like to build using the Algorand tools. So the developer environment has these three components, all right? You have infrastructure, your SDK, and a framework. So from an infrastructure standpoint, you're going to want to begin using the Algorand sandbox. It has 4 different components to it. It has the network nodes that you're going to need, the APIs, as well as the key management wallet and an indexer to be able to query the blockchain data. You can select from any of our available SDKs, and today I'm going to talk to you about the Beaker framework, where we'll use the Python SDK here. So Beaker is a smart contract development framework specifically for PyTeal, one of the 2 languages that you can write Algorand smart contracts in. PyTeal is a Python-like language. We also have Reach, which is a JavaScript-like language if you would like to do that. So with Beaker, we build a class that represents our entire application, including all of the program logic, its state, and the available methods to interface with that application. And the output is going to be 2 things. One will be some PyTeal source code, and the other will be an ABI specification JSON object. This is an application binary interface file that tells a user interface how to interface with the smart contract. So we'll take those 2 files, and we will bring them in. The first one, that PyTeal program, we need to install that source code into the Algorand blockchain. Upon success, it will return an application ID, a unique identifier for our application, and then using this publicly available ABI, any end-user device, your mobile wallet, your web browser, can simply connect to the smart contract and be able to call any of the exposed methods, passing any values that are required. So that's kind of the architecture of what it looks like to build with Algorand tooling. So let me give you an example. We have a number of examples for Beaker. They're right here. Head to the GitHub repo, and you can do it. We're going to take a look at a really simple one. Hello, Beaker. All right. So at a glance, there are just these 5 steps here. All that you'll need to do is think about the imports that you need. We're going to create that application class, create an app client, deploy that app, and then we're going to begin to call the expose method. So first thing we're going to do is stub out some code. This Python, very easy. First 2 lines up there at the top, those are your imports. 2 different libraries. One is PyTeal, the other one is Beaker. We'll import those, and then we're going to stub out the other 4 parts to our program. Let's zoom in on the first one, which is creating this application class. So as we see here, what we are going to do is to define our Hello Beaker class as an application, and then we are going to decorate an external method, and we're going to define this method simply as hello. Now it takes only one input value, a string called name, and it has one output value, also a string. And what we are going to do then down here in line 10 is we are going to write what our application will return back to the blockchain when it's called. And it's going to set some bytes. We are hard coding in hello, comma, space. And then we are going to concat that with the name, right? We're going to get the name from the value that was passed into our method. And then we're simply going to set that as the output and return that. All right. After we define this now becomes a definition for our ABI, and it will be exposed externally in that JSON object so that a user interface will know how to interface with it. Next thing we're going to do is begin with our demo logic here. We need to create this app client. Now the app client really does everything that you can think of when interfacing with an Algorand application using Beaker. So we're going to set our app client, which takes these 3 components right here. It has a client connection to our network. So in this case, we're going to use that infrastructure component called Sandbox. So establish a connection there. Then we will connect to that application class that we just created, the Hello Beaker. And then we are going to instantiate that there on line 18, the first time that it's used. And the last part that it has is that we need to have the account where we have the signing key for it. So we will do, we will get that from our sandbox environment. Again, there's key management in there, and we'll pop off the first signer within our key manager. Now next, we need to use the app client to actually create this, and then we will deploy this app to our Algorand network. This will return these values for use in the subsequent calls. So you see that we'll get back the app ID, app address, and a transaction ID when we call this create method. The application will now be installed inside of our local sandbox environment, and we can do the final piece, which is to use the app call client method to access that hello method that we defined in our Hello Beaker application class. And notice here that we have hard-coded in the name as Beaker, right? That string there. And when we end up executing this code, this is what it will look like. So we'll have the first 3 lines which return the output that we had initially when we deployed it. So we get back that app ID, the transaction ID, and the address for our application. And then we have the method being called here. So of course, we had hard-coded in hello, comma, space, and what we passed into our method was Beaker. So the output of calling this Algorand application is simply hello Beaker. And that is how easy it is to actually write your first smart contract on Algorand. So that was all done in the Algorand sandbox environment using Python and Beaker and PyTeal. Very easy for you to get started. Make sure that you check out the repo here. Then that's it. You know, this is where we are. I hope that I have inspired you to build with Algorand and begin developing your blockchain life. Thank you very much, and have fun building on Algorand.
Thank you, Ryan, for that great presentation. And now I believe that we have a question for you. It's in Korean, so I'll read it out for you in English. A lot of the layer 1 mainnets are using a POS-based algorithm to supply high transaction per second and low finality to provide really fast networks, or so they're proposing. Compared to these mainnets, what kind of competitive advantage does Algorand have?
So the competitive advantage that Algorand has with other proof-of-stake systems is probably in the block finality. So in the Algorand consensus algorithm called pure proof-of-stake, there is a multi-round sortation process that happens within this 3.7 seconds, where transactions are organized. There is a committee that is selected at random from all of the algos out there, and a subset of them are selected to propose a block. Then another committee is selected in order to soft vote on that, and then finally, one leader is selected from a third group in order to actually write the block in, and they will all vote on that from there. So when the block is actually distributed across all of the connected nodes, it cannot be forked. We have a mathematical proof that goes through and explains exactly how all of that works. And again, this work really comes out of the work that Macaulay had pioneered back in the 80s with zero-knowledge proofs.
Well, thank you for that answer. I hope that answered our audience's question. I think because of time constraints, that's all the time we have for the Q&A. Please give him another big round of applause. Thank you. Thank you very much.
Thank you.